You're listening to a 4x4 Radio Network podcast.
This silence has been brought to you by your friends at the 4x4 Radio Network. That's right, kids. You two can stare blankly at each other going, which one's going to start the show? Hi, Jeebers. Welcome to show 419. This moment of awkward silence. I don't know.
You're putting your own Easter egg in now?
Oh,
419?
I'm so keeping this in now. Welcome to show 179.
Yes,
and
better.
Again, I am Scott. I'm the slapstick parts guy. And I do not read instructions. I clearly now have completely derailed my own train of thought and now in a blind panic to get through the intro to the show because things were so awkward there for a moment.
Well,
Sitting directly across from me, almost for a while, they're going, well, is Mr. Kevin. Kevin.
hey guys, I'm Kevin, the old guy, the engineer. I've heard I've got a new moniker now, which I find humorous. And Scott will share that later, I am sure. But anyway, I'm the engineer, the guy who reads the instructions, uses the correct tools, and for the most part follows the instructions, unless I'm off on my own line trying to do something creative, which I just did.
Yeah,
But
there's a lot going on here.
So, welcome back to our little insane session here. And this time we have some different things to talk about, don't we?
Mm-hmm. And before we talk about that stuff, well, as always, we share what worked for us and what didn't. It's up to you to do your research, read the instructions, and make sure you
Always
follow them.
Please follow the instructions, unless you really know what you're doing, in which case, by the way, just in case you haven't figured it out, if you don't follow the instructions, you avoided the warranty.
What's that?
Exactly.
Man, now that the show is barely off the rails.
Yeah. Well, I got to start out with a shout out to
All right.
to Maverick Forge. Thank you very much for the emails. Although Scott was a little bit like, I'm not good enough, huh? whimper. Yeah.
Right to the old ego. Ow.
I answered your question. Hopefully you've already gotten that email, and apologies for it taking a while. And for those that don't know, I think I mentioned it probably, 12 shows ago that my computer hard drive decided to absolutely, go completely down the toilet. And I just flushed it and got a new one. The problem is that when I tried to reconnect to On the Trail podcast, it went, we don't know you. No, you're not allowed. No, can't do that. Every time I tried. No, Scott's like, well, it's just this. It's that. Yeah, I know what it is. It's written in my little notebook. And finally, with Scott here last week, I said, stand there with your phone. So when it gives you the security alert, you can say, yeah, it's okay.
11 security alerts later over 7 different email addresses.
Seriously, it just went absolute nuts.
Yeah, I'm just sitting there going, wow, man, okay, as I'm answering, like, okay, stop.
So I'm finally back on our own email address. Prior to that, Scott was responsible for being the receptionist and forwarding all the emails out, which
These people are entrusting us to help them with their problems, and we can't even figure out our own darn email.
yeah, well, I'm not sure whether it was Microsoft, Apple, Google. They all had a part to play in this.
Yes, they did. That's hence the 11 emails.
Yeah, somebody was not handing off security certificates because I checked everything was current. So anyhow, we are back. And what Maverick was asking was a little rundown on, long arm versus short arms, pluses, minuses, and opinions. And pretty much they're all about opinions, unless you get a really cheap kit, in which case it's all about broken parts.
And when that sponsor. Oh, wait, we don't have sponsors.
No, we don't. We have friends of the show. So I thought we'd go ahead and share just a summary of that because it was a rather long email and the show's not quite that long. But suffice to say that there are differences, obviously, between long arm and short arm, and it's more than just the length of the lower suspension arm and upper suspension arms. The most obvious, it's the angle, okay? The longer the arm, the closer the arm is parallel to the pavement. The more you're parallel to the pavement, the more bumps, and I've talked about this before, when you hit an object, a hole, a bump, or a speed bump, whatever, you have a coil spring and a shock to dampen it for the vertical motion, but all the horizontal motion goes back through the lower bar into the frame, and it just, you feel it is slowing down, either sometimes abruptly, sometimes not, except when that arm isn't parallel. And when it starts to become angled, and the more down it becomes angled off of parallel with the ground, the force going up that lower arm is essentially split mechanically into two vectors, which is just a fancy way of saying directions. One is still horizontal, parallel to the ground, goes into the frame, slows you down. But the other part is now going up in through a bolt into the frame under your butt, which kind of tends to make your Jeep ride a little worse. The steeper the arms, the more harsh your ride is, and the less control you have, because you have an uplift into a point behind your tires that you can't control, doesn't have a spring, and doesn't have a shock absorber. So that's the big difference, is the longer the arm, you're moving the pivot point further back, which by keeping the front point the same, the further back you go, the lower the angle gets, and the better the ride will be. Of course, we're all looking at the other side, is also a longer arm can swing longer before it runs out of swing, and you get more articulation. So those are the two obvious ones.
But one other thing too, the trade-off to the long arm suspension is when you drop off obstacles, you now have this long control arm that is probably going to take the beating of the obstacle. Correct?
So you want a good strong one. That's if the obstacle is behind you.
Yeah.
But the truth is, you're also going to drop off onto most of the standard length arms too. Sad to say, there's nothing that's that close. Last vehicle I was aware of with a truly linear front suspension was the little British sports car, the Triumph, not Triumph.
MG?
No, the TR. The little one that, oh, shoot. Now I'm feeling really bad. I can't remember this. It'll come to me later. But anyway, and it actually had a true linear front suspension, went straight up and straight down. And, of course, that made it very stable on the track. The Morgan Plus 4, had a linear suspension. So,
the Morgan Bug-Eyed Monster. I remember that.
No, not the.
No, who made the Sprite, which was considered the Bug-Eyed Monster?
Well, the Sprite was made by British Leyland. Was it British Leyland or one of the other cars?
Okay,
Morgan is the company, and the Plus 4 is the car.
Gotcha. All right.
So the other things that you kind of get to is he asked a question about or made a comment in his email, which was very observant of you, that, the other thing with the swing arm systems like we have in the 4 links is that if you lift it with a standard length arm, obviously the more you lift it, the more it bends down. The more it bends down, the shorter your wheelbase gets. Yeah. Which is true in an arc. But most manufacturers lengthen their arms to their static position so that the wheelbases are the same. But you still do have to realize that you have changed the geometry. And as I told him, I said, one of the biggest things is that they can do a lot in the design of the suspension system, but it still boils down to you, and your brain has to get programmed to the new handling of this altered suspension and become cognizant of what it's going to do, and what the geometry changes are going to be as you make different motions.
Well, that's kind of one of the reasons why Quick Bull Byline is why we talk about, if you do get a stock Jeep, take that off-roading.
Yeah. Find out what what your starting point actually is. The biggest thing, as I told him, is in my experience, is between manufacturers would be spring rate and shock dampening. Spring rate, of course, we've talked about that way, way, way back in, oh Lord,
way down upon us one.
Two-digit numbered shows.
Yeah, it's way back there.
And it's just how many pounds of weight causes 1 inch of deflection in the spring. And, you can get a lift by putting a really stiff spring in. The problem is that then you have a really choppy, bouncy ride. You can do a really soft spring rate, but you're going to take more coils to get the same amount of lift, more winds and basically a longer spring. But it's very soft, and it tends to be kind of bouncy, and you've got to have a shock that goes with that to control that. And there's a balancing act to all of that kind of stuff.
Yeah.
The key there is, of course, a softer one is nice, but when you slam on brakes, you get really a lot of nosedive because it's not an instant bump that comes back. It's, prolonged. And what does that do to your steering geometry? So it goes back to being a balancing rack. The other thing in the subtlety is unsprung weight. That part of the weight that's carried directly on the axle, not on top of the spring. Well, the spring itself is not a part of that. And soft rate springs are bigger. They're heavier. There's more of them, so they increase your unsprung weight. And I'm not going to go into the whole suspension geometry nightmare, but it's not a good thing. Lighter is better than heavier. That's why smaller tires actually do ride better. Yes, I know big tires get over things easier, but we're talking about, the compromises. Mm-hmm. And then the last thing that was touched on is what does a lift do to your U-joints? We take it for granted in most of the circles because we've all dealt with it for so many years now. But for those of you that are listening for the first time, understand that if you lower your axles down and don't drop your engine and transmission to match, nobody does. We do some slight adjustments, but you're going to change the angle from the output on the transfer case going forward and the output on the transfer case going backwards. Mm-hmm. There's an interesting news flash is because you see a lot of cattywampus angle drive shafts coming out, but most of the manufacturers tell you the maximum angle of deflection in a U-joint. And what that is from the pinion going into the differential to the drive shaft and from the drive shaft over its U-joints into the transfer case. For a single cardan, that's one U-joint in that coupling, and we'll talk about the other kind in a moment, is 3 degrees. And you see a whole lot of Jeeps out there, way more than 3 degrees.
Yep.
Now, I will clarify that the manufacturers don't say they're going to fail immediately if you go over 3 degrees. They actually produce a chart. Spicer, in particular, produces a really neat chart on their tech page. And Spicer being one of the bigger manufacturers of U-joints in terms of sheer volumes of what comes out in stock vehicles all around the world. And it's up to a point. There comes a point where you have immediate failure, but that's usually not in the U-joint itself. That's usually when the mounting surfaces, the one on the pinion and the one on the drive shaft, collide. Mm-hmm. The motion's so big that metal meets metal. But the rest of the time, it's in lessened life shaft. You go 5 degrees, it's still going to run. It's just not going to give you, let's say, I don't know this, but let's say you've got 300,000 hours of life at 3 degrees. You might only have 250,000 hours of life at 5, but you may only have 50,000 hours at 10 degrees. So you can run it. It may or may not vibrate, but, it's just one of those things. The other thing you learn about is something called a double cardan drive shaft. And it's simply where 2 U-joints are coupled together back to back, forming a short, and I understand short, about 3.5 inches long drive shaft section with both an input yoke and an input U and an output U, which balances the normal cyclic speed up, slow down of a drive shaft going through a turned U-joint. And that's what we should be doing. That's why we have to do slip yoke eliminators on the back of lifted Jeeps that have a regular slip yoke. So you do an SYE to put in a flange or a saddle kind of mount, either one, and then do a double cardan because that takes the vibration out, and then go down, and therefore you can rotate your pumpkin of your rear axle up until you have a lot of guys I know try to shoot for 0, and that's not a good thing. You want it between 1 and 3 to keep lubricant moving around inside that U-joint. Yep. The front is not so easy. Did you know the Jeep comes factory? All of them have come with a double cardan on the front drive shaft at the transfer case. Well, I shouldn't say that. The very early ones with the pencil shafts, the earlier CJs and that kind of things, did have a pencil shaft, and they had big warnings: do not operate over 45 miles an hour in 4-wheel drive because it would shake the out of you. But anyway, you've got a problem, is that you couldn't rotate the axle until you have a pinion angle of a lifted Jeep between 1 and 3 degrees. That's right there at that one pinion, the center line of the drive shaft to the center line of the pinion gear.
Right.
But unfortunately, as you raise the pinion angle, you lower your caster. And you kind of need caster to be positive so that the Jeep actually goes straight down the highway. Negative caster is not good. It's very unstable. You'll get shimmy, shake, all kinds of problems, even up to and including death wobble if you get an extreme negative caster. And death wobble is the same thing as that shopping cart with the bad wheel that you push down the front, goes as you try and drive. That's the equivalent of self-amplifying failure.
I do have a quick question because you started at the beginning of the conversation. Now, when you talk about U-joint failure, does it matter if you use, like, let's say, an off-brand drive shaft, like the Cattywampus you mentioned, or if you use, like, a Gulf Coast drive shaft? I'm just trying to make a joke and use the Cattywampus drive shaft as a moniker for a manufacturer. So I'm going to go back and take my joke back.
Okay.
But on the serious note, though, I do have a question on those U-joint things.
Yeah.
You mentioned about getting the stuff, you want at least 1 to 3 degrees.
To cause the lubricants to circulate
So
in the inside of the U-joint around the needle bearings.
what's your preferred, because I know this is a hot button topic, just a quick little byline, when it comes to drive shafts.
Drive shaft.
Drive shaft. Do you prefer lubed or ones you have to lube?
That's not drive shaft. That's why I asked drive shafts. That is the U-joint you're talking about.
Right.
Do you prefer greasable or non-greasable?
That's a better way to say what I try. So.
They're both good, and they both have weaknesses,
Okay.
as with everything. And whether or not either one survives effectively is up to you, the owner. If it's a lubable type drive shaft, okay, you have to remember to lube it. All right. And its advantage is that if you do actually lube it, you will push out any contaminants from playing in water. If you're in heavily dusted areas that you might have dust getting past the lip seals, you can flush that out. And you cannot do that with a sealed U-joint. On the other hand, a sealed U-joint doesn't need maintenance. It's designed with lube for life. If your lube for life plays, though, into that very earlier topic about how many degrees of deflection. If you over deflect and run it at too much of an angle, the heat build up, and that will tend to push the lube out and shorten the life, and you can't put anything back in.
Okay.
All right. So one is less hands-on, but less tolerant of extremes. Everybody says, it's stronger because it doesn't have a hole bored down the middle. I got news for you, folks. If you go to any structural engineer and ask them about what's more solid, a pipe or a rod, they'll all look at you. Every one of them will go pipe. There is no stress in the middle section. The extra weight actually causes problems because it isn't, a clear-cut area, and it tends to cause problems. Now, in the case of a U-joint and a forging, mox nix. You can find test results that show a center drilled is stronger, just like a center drilled axle, is all what they run in the buggies because it gives a little bit of spring and a little bit of bounce.
Okay.
But you can also find reports that show, no. In dead weight tests, the solid bar is stronger. Well, okay. Pick your failure mode, folks. Pick the one you like. There's no wrong answer is what I'm trying to get to here. Both have very good sides. Both have some challenges to them. How's that for a straight smoke-filled answer?
That's perfect. Because the other question I did have, because as a conversation we had a couple of days ago about how I got flamed on Facebook, and it turns out I wasn't the target of their ire. Why don't they use constant velocity CV style shafts?
Not CV.
But you know what I mean.
Okay. First off, let's get the terminology straight since we have listeners out there that seem to be paying attention. Folks, a regular drive shaft with a double cardan or a single cardan, and the cardan is a different term for the U-joint, that little crossed piece of metal with caps and bearings on all four tips that two of them oppose each other, and they hook to the drive shaft, and the other two hook to the yoke that goes into the transfer case or into the axle. And the number of those, you have the double cardan, which is two of them side by side, as I said. And it's interesting the way they're mounted, the castings that they mount into have a pin and ball in the center. And when the lube in that center ball goes out, you hear the angry sparrows, as we call it. And, that is to keep the balance of whatever angle the pair is operating at let's say you've got a 6-degree deflection. Well, 3's in one, 3's in the other. It's always centered. Now, that is a cyclic U-joint. People called a double cardan a constant velocity because the output from the transfer case goes through the double cardan, and the output shaft runs at a relatively uniform speed. There's no cyclic speed up, slow down, speed up, slow down. A single cardan, on the other hand, because as you lean the drive shaft down at a steeper angle, the top part of the circle described by the U-joint of the two caps that are hooked to the drive shaft, not the two that are on the yoke coming out of the transfer case. That's running in a perfect circle, unless you've trashed your drive shaft or your transfer case. But those other two describe, when you're looking at it straight on the center line of the output from the transfer case, it's an oval. Well, when you get an oval, you're getting different radiuses. Different radiuses mean different speeds. So literally a drive shaft, as it cycles through, as the drive shaft, the output yoke, let's pick on the output side of the transfer case yoke, is vertical. The drive shaft's moving at essentially the speed of the output. Okay. But as you get down 90 degrees, you're running at a lower speed because of the circle being described at a different radius. Smaller radius means less speed to get around that circle because it's a smaller circle.
Right.
But then it immediately in the next 90 degrees speeds back up to full speed. But then it slows down again as it makes the next one, and then speeds back up till you're back up at 12 o'clock. So a drive shaft with a single U-joint sees a double harmonic every 360 degrees. Speed up to slow down, to speed up to slow down. And it usually is absolutely not a problem. That's why drive shafts are hollow and a little springy so that they can absorb some of it. The other is you put your output drive shaft the exact same clocking to your differential. So the differential should be vertical when the transfer case is vertical, because guess what? Then those cycles of speed up and slow down actually make the axle pinion turn in the same smooth circle that the transfer case is. But your drive shaft is still going,
right.
And that's okay if they're designed properly and built properly. When you put in the double cardan, that's why you can't run after you do a double cardan at the top. Now you have a smooth drive shaft. You've got to make sure that the lower U-joint angle is 1 to 3 degrees, 1 for life, but 2, usually you get to around 1 degree and you're moving the lube around, but the slop, there's thousandths of an inch of, or you wouldn't be able to put it together, in that shaft, pin bearings and cap that can absorb some of the vibration. Plus the flex in the drive shaft can absorb the rest. So you get the appearance of smooth output. You go beyond that, now you're actually creating vibration because your pinion angle's wrong. Okay. That happens both front and back. So that is never a constant velocity. A true constant velocity joint is like a Burfield or one of these other styles, often used on front-wheel drive vehicles where you've got a cage with 3 to 6 balls, rollers, all kinds of different things. And then the housing that drives that has slots in it that are in line with the output shaft of the transmission, transfer case, whatever. Right. So that the balls roll up and down in their slots, transferring power to the lower piece, which can also the balls transfer the rotation smoothly. They end up anywhere in that slot they need to balance the velocity. That makes sense?
Yep.
You've got this free moving component. The downside, everybody, we should do those. Well, yeah, some like Land Rover loves their Burfields. They can't handle that much horsepower, because you are working basically with 2 interlocking spheres with little round balls in between them in slots that hold them all together. And there's a lot of pressure in a very small area, and they tend to go south. They need a lot of lube. Think about your CV axles in little sports cars, imports, and that stuff that have that big rubber boot. How long will a big rubber boot survive in a Jeep off-road environment? It would be shredded in short order. And then, by the way, you've got dirt, water, and everything else in there. The grease is washed away, and a CV joint will self-destruct very quickly if it's not swimming in lubricant. So I'm sure it's been checked. There are brands. I can't think of the name of the orange ones that you can get for the front axles.
Yeah, I literally have been trying to remember that myself and escaped.
And you guys know it. They're an upgrade. And they're very expensive. They're very, very good. Please don't get me wrong. They're fantastic. But you have to take care of them. And they're used that way because in an axle environment, you do have a fixed speed out each one of the shafts. And Scott's furiously trying to dig up a reference.
You got it going, man. By OCD, I got it. Remember it now.
So anyway, that's kind of he kind of pulled me off track there a little bit. The key back to what I was talking about with the drive shaft. That's why, by the way, on the front axle, you would love the front axle pinion to be within 1 to 3 degrees of the front axle's drive shaft angle.
RCV
performance. There we are. Sorry, RCV. We just had a brain fart.
Sorry, I had to stop. I had to do it,
and it is. It's a great axle. It's an axle shaft assembly and stub axle out front. The other part is of course your angle between your axle, your pumpkin pinion, and your C knuckles. What your oh God,
knuckle attaches to
ball joints.
Ball joints. Okay.
Can you guys tell I'm tired? The ball joints, that angle's fixed to the factory. It's welded. All right. Typical TJ axles are 6 degrees between those two. There's a variation off of a perfect 90 of 6 degrees.
Right.
Well, that was because the drive shaft in a stock TJ was almost level. And so with that almost level, a little bit of a tilt, and the 6 degrees, you could get 7 degrees of caster on the front, which is why the factory ones handled fairly well. We lift them. We drop that down. The arm swings down. The pinion has to go up. We lose it. Okay. Small lifts, you get away with it. You can get down to 5, and it doesn't handle quite as crisply, but it's not too bad, particularly with the fact that when you go with a slightly larger tire, you get a higher axle. The higher axle means that even though you have only a 4 degree or 5 degree tilt, the actual what's called trail or lead, some people call it, which is an imaginary line between the ball joints hitting the ground. Where does that hit in the tire? And the actual contact part of the tire. Well, that invisible dotted line should be leading the contact point by a certain distance to get that return to center feel in the stable, ride. And as you go up, that distance gets smaller. But as your tire gets bigger, well, even though you have a smaller angle, you're going up more, which gives it more time to grow. And you counteract some of it. And hopefully I haven't confused you completely at this point. But the key is that you've got 2 competing numbers that want the same center line turned. The wheels are happier if the pinion goes down. The pinion's happier if the wheels stand up straighter. And you kind of have to make a balanced decision there. And that's why front end alignments on any Jeep is a problem. Now, some of the XJs had the same front axle as the TJs, and they had 10 degrees in there, which gave you a 2 degree comfort. And I ran with that for a while. It still wasn't perfect. You really want to make it all go away. You either cut off the C's and re-weld them at whatever angle you want. And don't do this. If you're going to do it, great, but don't do it until you got your lift. And put the thing up and put it all together and set the axle on stands with the full weight of the Jeep on it and set your pinion where you want, and then go, okay, the factory, they need to kick another 5 degrees, forward. And then cut them off, because otherwise you're going to be playing all kinds of headache.
Yeah.
And you have to have an alignment bar to keep the center line alignment for your axle shafts true. Oh, and you got to make sure that the welds are solid since you cut off cast iron. It's et cetera, et cetera, et cetera. Or you can take my route, which was by far not the cheapest, and I saved for several years. I had an axle made with my specifications, and I told them what I needed for the included angle. And that was already measuring because I'd already run my drive shaft. I kind of knew where I had to be. I knew what the factory was. And so I was able to say, okay, I am short 4 degrees. And no, actually I was probably short 6. So I did 12 degrees included. But would that work for you? Possibly, possibly not. Can't tell you. I do know that mine handles well enough, and I found out my picture that was posted years ago got some people's attention that, yes, my Jeep really did run on the Daytona track and cross the finish line, not on the high bank, but on the lower, what they call high-low, which is the low bank. They wouldn't let us on the high bank. And it could run all the way at the upper edge stably, and I got a picture of my Jeep flag flying, ripping across Daytona, which is really odd to look at a Jeep on the Daytona Speedway. Granted, compared to the cars that normally run there, I wouldn't even qualify to pick up their tire, little tire marbles.
Yeah, Jeep needs to be on the brickyard because it's a brick.
Yeah.
But before we go on to the next subject, because you brought this up, and this is a question I want to ask.
Yeah.
What are your thoughts on ball joint eliminators, or is that something you got to do a little more research on?
No. All ball joint eliminator kits are converting the ball joint into a kingpin system.
Okay.
And folks, there's not a lot of difference, and there's a whole lot of difference at the same time. A kingpin is used in a lot of cars and trucks in the 30s, 40s, and 50s. And it's just simply a vertical shaft in a bearing. It cannot move angular wise. It can just turn. Okay. It can rotate just like any other shaft in a bearing can rotate. It's only applicable when you have fixed upper and lower mounts. Any kind of an A-arm suspension, independent suspension, where your knuckle has to not only turn for steering, but also as it compresses, the arms move differentially to keep your camber at a point where your contact patch never changes in position relative to the car. Kingpins don't work. Okay, because they don't rotate any other direction than in their center line. All right. However, they're still bought and used on industrial trucks' front ends. It's still a kingpin system. It's still used on heavy equipment like tractors and those kinds of things that just have a fixed axle. They would work and do work on any kind of a fixed axle vehicle, including a Jeep and a Dana, 30 and a 40 and then the trucks and all those things. They are somewhat stronger. All right. But
here comes a but.
Well, there's always a but, is that unless you're building a radical rock bouncing rig, ball joints are strong enough. Okay. Ball joints rarely fail due to just being used. They wear out and people don't change them. And then they fail. They pop out because they're a wear item. Well, I got news for you. Kingpins are a wear item too, and there's bronze bushings in them. But since they only rotate, and you kind of know when they become loose, they start rattling and you start having serious steering wear and your tires start cupping, people tend to maintain them because it's very obvious when they've worn out. Ball joints, not so much, because ball joints can wear a lot and they become looser, but because they are a ball in a socket, they automatically self-center in the top of the arch. So if you're going from the difference of a basketball fitting inside, a bowling ball fitting inside a basketball shape, that's a tight fit. But What happens is, under normal circumstances, that would be in a line. Same thing happens if you put a tennis ball inside a basketball with the weight on the tennis ball, it's still going to find that top center. The question is, what happens when it gets bumped? It goes way off to the side and comes way back, or you hit a hard enough shock that it comes out the bottom. Okay, it's lost its capture. So that's where U-joints are typically the biggest failure. Not saying that people who smack a rock at 40 miles an hour, doing the Baja 1000, and they rip the axle off, that the thing didn't fail. All right, but you'd probably rip a kingpin off as well. However, if you're in that realm of rock bouncer, and maybe the gravel hill climbers and the guys that are just flat out, you need strength because you're going to put 1,000 horsepower to the ground and you have to fly over whatever, then, kingpin systems may be your right answer. Okay. Again, for most of us that alternate a trail ride or three, and even an aggressive trail ride with I got to run down to Big W and buy some fishing stuff, and tomorrow I got to go back to work. Ball joints are probably better. Ball joints are more fault tolerant. They can take misalignment without being in a bind. Kingpins can't. They have to be precisely in line with each other, center line to center line, or they bind. So everything has a plus. Everything's got a minus.
Well, actually, it's kind of interesting. Great segue when you talk about things wearing out.
Uh-huh.
So why don't we tippy tire into the garage here real quickly?
I suppose you and that, wherever you came up with that phrase, guys, I don't tippy tire anywhere. I don't tiptoe, period. I'd fall over and hurt myself. Tiptoes, my God.
My mom actually came up with that, saying tippy tire. How you feel now, Jerk? No,
Fine.
I'm just kidding.
What Scott is so inelegantly referring to is the fact that we've talked many, many times over many different shows of my life with my Rockslide Engineering Power Steps. Mm-hmm. And, I've gotten lots of comments. Well, you should get rid of those. You have nothing but problems. No, I don't. I am reporting what problems I do have, whereas most people don't, because I'm trying to share information with you. I love the steps. I love their function. Mm-hmm. And most of the time they behave. But you've also got to remember, I've had them for 5 or 6 years now.
Easy, because we started the show and when you got them.
Yeah, and the actual thing I'm experiencing now is wear, okay, particularly on the driver's side. Because while my wife rides with me on trail rides, when I drove this thing to work every day, when I then started driving it to the airport and leaving it in the parking lot, I was the primary driver, and the steps were swinging anywhere from 6 to 12 times a day. And it was always the driver's side door.
Yeah.
And so the passenger side door, because it wasn't moving a lot, the lubricant tended to seize up. The driver ran for beautiful, but it started drooping. And as we talked about when we were up at Smoky Mountain Jeep Invasion last fall, she dropped open.
Yeah.
And so we teased you a little bit last show about the fact that Rockslide Engineering has come out with a gas strut elimination kit. And it's kind of a neat concept. In their their current generation of steps, they use a simple coil spring because gas struts do tend to leak gas over time. Like we've said on the show, if you've owned any car since the 70s with a hatchback, a hood, or whatever with a gas prop, you know what we're talking about.
Yep.
It slowly takes more and more help to get up, and then eventually you put it up and lean over, and it comes down and bops you on the back of the head because the nitrogen has leaked out. And it's that same ram type of system. It's shorter. It's only a 9-inch stroke ram. I even know this, that it's a 40-pound ram, 9 inches long, because I've replaced one. Mm-hmm. It leaks too. And because when the steps are up, it's in the compressed position, which is the most leak-prone position for these cylinders, because when they're open and they're fully extended, the pressure internal is as low as it's going to get. Whereas when they're all the way back, it's as high as they're going to get. So, they have come up with a spring for the new models, and they offered a redesign to replace the gas ram with a spring in the current models, up Gen 2 on, I believe. Right. I looked at them, I'll be honest with you, but that wasn't my problem. My problem was differential settlement between the front and the back.
Right.
My ram was closing them fine. I just always had this droop. And there is a balance bar that is hidden up inside the step that you can adjust to help eliminate that droop. Because, folks, this step is kind of a really neat system. It uses... Well, with a lot of the other power steps that the motors come down, they have a parallelogram, which is just 4 pieces of metal linked with pivots at each end so that you have a square, but you can scissor it into a bar, or you can scissor it into collapsing. It's just a very simple, the mic stands we're using here are a parallelogram. That's how you can move them and everything at the end stays straight. If you've ever seen the man lifts that are double bars, they scissor up, they scissor down. Those are all parallelogram systems. Whereas most manufacturers just use a small version of that and then swing the steps down. They decided to actually make the step and the two of the arms part of the parallelogram with just a connecting bar that's hidden up in there for the final adjustment. And I think it's an elegant solution. It really does work. But, you know, it's hard to adjust. That's the only thing I'll say about it is getting up in there on your back. You cannot adjust it closed without taking the step off, putting it on a frame where it can open and close, but you can get to the back. It's probably what they do in assembly. Well, to pick up where we left off, that's kind of where I left off, is that I had the droops. And I was looking at their system, and before I went ahead and got it, I wanted to make sure that that was my problem. Okay. I actually did exactly what I said. I got a pair of cheap sawhorses, the little plastic ones, I don't Stanley or whoever's, that you can stick 2x4s in vertically, you know, not standing up 8 foot long, but, you know, the 4-inch side up, and they fit in little slots, and it makes a really nice little stable system. And I drilled 3 holes, took off the step, walked over, slid it over bolts that I had in those 3 holes, and bolted it on. And I bolted it on such that the 2x4 actually was on the wrong side of the mounting flange. Remember that, Scott? It was where you put your feet, because I didn't need that area. I wanted the back side, which is where it mounts typically, completely open to the mechanism. And then I could operate it, providing myself a little power and, you know, swing it down, swing it up. And at that point I was like, oh, okay. I bought myself a similar 40-pound type spring. You remember those were the heavy ones.
Yep.
And I tried hooking it up, and I put a pull on it, and I was like, is this going to improve the situation? And it did not. It turns out that if you have just one end droop, typically the leading edge, it's not due to that spring. Okay. It's not a power of closing kind of an issue. So I started digging around, and Scott was there when he came over to help. And what we discovered is there's a gear motor system that sits back there, and it's actually, believe it or not, it's a Ford window winder for a power window on a full-size truck or car. It's a pretty healthy motor. And instead of the gear that turns the window system, they pull that off. The motor assembly comes stock with like a square shaft that you can slip the gear on, and it provides the friction to drive it, you know.
Yeah.
Well, they make a crank. They put a crank on it, and they put it in a frame that's limited that crank from about 180 degrees of motion. They set up a computer. This was genius, guys. My compliments to you. That monitored the current draw, because when you stall an electric motor, okay, the current goes up if the speed goes down. And they put a switch, an electronic version of a switch in there, so that when that motor hit the stop, obviously it would immediately start to spike and it would turn the power off. So it would never strip out the gears of the motor. It also doubled, this is what was cool, as your safety. You put your hand in there when it went up, it wouldn't pinch your hand.
Yeah.
It would, you were standing too close and the bar came down and hit you in the leg. It would hit you, but it wouldn't even bruise you, but it was like a bump, and it would stop. Well, that was that same circuitry, all in one: open, close, security, and safety. Right. I was like, that's smart engineering, you know. Therefore, you don't have to pay for 4 different circuits.
Yeah.
There's one. Well, anyway, to get back, that crank now, you got to get that power to the parallelogram. And to make it a clean install, they put the pivot point. Most of us would grab either the opposite corner of a parallelogram or at least a top and a bottom link and swing it up, because that's where the least amount of pressure is required. Well, no, they went about up in the body, up at the pivoting corner, they call it. That's the closing, scissoring corner, and put the pin up there only about an inch down. So that lower step hangs down, 12, 13 inches? 12 inches, let's say, 12 inches down. And it goes up in an arc where the whole step rises that entire, I think it's 10 inches goes up and forward 10 inches to close. But all that force is right back about 2 inches down from the pivot point in the back arm. That's a lot of push. Hence the gas ram, 40 pounds of pressure. But that's asking a lot of that. There's a little link, and I call it a dog bone because it's a little piece of metal, 2 holes in either end. So that's kind of got little knuckles at the end with holes in it, and it's got a crook in it to clear the mounting arm so that it can swing up and in. And so to me, it looks kind of like a cross between a metal dog bone and we've always called parts in cars that were, just a piece with 2 holes in each end to bolt through, dog bones. Mm-hmm. So it's a dog bone to me. It's a bent dog bone. And I showed it to Scott and I said, I think I found my droop. Well, after 6 or 7 years, the holes in the dog bone, despite the plastic bushings, were no longer round.
Yeah.
They weren't even remotely round. Mm-hmm. The pressure developed as that thing was slamming shut, elongated the holes. And I'd always kind of looked at that, but I'd never paid attention. It didn't elongate them so that the dog bone was longer. It was wearing away in to the center of the dog bone.
Mm-hmm. Making it shorter.
And I took a measurement, and I had about 40 thousandths of an inch on each end of elongation. And I won't bore you with the math, but you can do the math on the angle loss.
40 thousandths times, 12, 14 inches?
Yeah, well, plus the length of the step. You got the arms and all that stuff. And guess what? I get about a half-inch droop. Guess what I had? About a half-inch droop. Mm-hmm. And then Scott just looks at me because I'm going, well, I wonder if I can get those parts. And he goes, why don't you just make them? It was one of those, yeah, good point. So we walked over and I grabbed myself some piece of 1/8 hot rolled steel, a marker, traced, cut, made it bigger, made sure I had clearance for the clearance part of it. I made it heavier, not hugely heavier. There's pictures. Maybe we'll get them up on the interwebs here, and re-drilled the holes in the correct location. No fancy tools here, folks. This is not a CNC. This was a 4-inch die grinder, a 1-inch strip sander for detail work, and a regular old drill press. Mm-hmm. Picked around with the metric, I think it was a metric step drill that got the perfect hole for putting the new bushings in, popped them in there, put it in there. Thing went down, thing went up. She's closed up tight as a drum and beautifully. And
closed with authority now.
Yeah, well, that's because I decided to help a little bit. Yeah. There's a part 2 to this. And this is what I had to laugh about. I decided that, putting all the force in that one corner, trying to push up this, it'd be like holding the end of a baseball bat in one hand, right there at the base, the knob. Now, take 2 fingers about 2 inches away from the end of the baseball bat with it hanging straight down, and now try and swing the baseball bat up so it's all the way up horizontal and hold it there.
Yeah.
With your hands right next to each other with all that baseball bat and way out there. Mm-hmm. That's the concept we're talking about here. I said, well, you know what? I got another arm that right now did nothing on the other end of the baseball bat. And because of the way it was made, they used the same forgings, or not even that, they're bent, pieces of steel, but they're all the same pieces. All the braces are the same and all that. They just didn't use the holes in the pieces they didn't need. There was a hole up there in the front arm.
Yep.
So I ended up putting a bolt with a spacer and a Heim joint, a little rod with an eye bolt that I did have to, because I was impatient and wouldn't wait to order an eye bolt with a 1032 thread, which is all you can get for these small rod ends. But I took a piece of 1032 rod and a piece of it's quarter 28 rod. Yeah. And then standard 1/4-inch eye bolt rod, cut the standard quarter 20 off, threw it away, ground a point on it, stuck it on the end and welded it to the quarter 28 and made my own eye bolts, which may or may not last. We'll see. Looks like they're fine. Made a bracket very similar to the one that shows up into the fitting kit that Rockslide Engineering makes to upgrade, except that I put it on a forward brace way up in the nose because I could get to it. My steps were off. They designed the kit to be done on the ground. And instead of a 40-pound spring, I just put a little 20-pound helper spring. And just to kind of take some of that front load. Mm-hmm. And now with that, I probably should go down to 10 pounds. It's plenty, but 20 is what I had. And it closes with authority without being violent. I mean, it sounds like it when it was new. It comes up and has a very solid thunk. I also replaced all the stop bushings because they were pretty well shot. Yes. And so that's been the project that's been going on over the last couple of weeks while I kind of did some figuring and futzing. But here's the punchline. The steps, do I love them? Yes. Still, they wore out. They're no different than my engine, it wears out. I'm going to overhaul it. Hinges in the door start to sag. You rebush the hinges. Those kinds of things happen as wear and tear comes along. The fact is, I've discovered that these steps, if you've got a little bit of time to figure it out, are very serviceable. The parts came out of the McMaster car or the, I think it was McMaster car catalog.
Yeah, I think it's what
and they're readily available. They're not terribly expensive. I'm sure you could probably get them to replace the dog bones, order some new ones if you wanted to, but they were really easy to make if you're the least bit fabrication handy. No bending, nothing fancy that way, just trace, cut, drill, done. Scott made me be real fancy, and I did have to clean them up and paint them. So they.
No, you hate rust.
I do. I do. But you were the one going, you're going to paint it, aren't you?
Oh, yeah, no, I had the.
So you're supposed to paint those things in a fashionable format. You have to use the same black that slightly alters dud.
But anyhow, I am very happy to announce that they are back to all but new status.
Yeah.
And the binding issues that I had, I found out it was interesting being able to look at the unit operationally from the backside and actually use it, not try and hold it still while I put the steps down.
Yeah, no, what you did was great because it gave you the inner workings. It was like almost like a step MRI. You were able to see the inner workings.
Yeah, and cut away kind of a view. I saw that and it was probably me during one of the reworks on the passenger side when it was just sticking consistently. There's a series of plastic shim type washers that they use to align the parts, and the alignment when they're down versus the alignment when they're up are not the same. And that has to do with other things about pivot points and that kind of stuff. And I had quite a bit of bind on the up stroke that could have contributed to some of the sticking issues that I had in the past. And most likely I'm the one that did it because I was aligning it with them down, not with them up. Now that I could see it up, I could also see that tie bar between the uppers and was able to do some very happy little fine tunes to make the bar parallel for the lower step when it was up. Right. And in general, just had a better idea of how the steps work. The weirdest thing was something Scott discovered, and I'm going to have to get a hold of the guys at Rockslide Engineering and ask some questions, mostly for curiosity. The dog bones are gone, but he noted something that I didn't because I was busy just making new ones.
Yeah.
They were two different colors.
Yeah.
And he goes, is this aluminum? I'm like, well, it doesn't feel like aluminum, but it was non-magnetic. We had, I think it was stainless steel. It's either a hard alloy of aluminum or stainless steel. The other's plain steel.
Right.
So I got to find out, was there a crossover, guys? Because my passenger one had a dog bone made of one material, and the other one had a dog bone made of steel. They're now both steel.
Oh, yeah.
So that's just a little inlight of, a verbal version of what's he doing. Scott took lots of pictures, and then he dumped them all on my lap, gave them all to me. And I'm like, yeah.
I'll tell you what, I'll post the pictures, you write the words. How's that sound?
That's fine. That's fine. I think after this show, they'll go, oh, okay, now I see what he's talking about.
Exactly.
So it's just one of those things with owning a Jeep. You can bitch about it, or you can figure it out and fix it. And I have more fun figuring out and fixing it. Not saying, again, that there's anything wrong. I ran mine to the ground. They've been painted, repainted. I've got to do it again. I got more, gouges and scratches and wear marks and that kind of stuff. I've got to the point, I don't think I'm bragging, Scott, that I can field strip those steps off that Jeep in less than 2 minutes.
It is a NASCAR pit stop. Well, to touch a little on the subject, though, because originally, because as Kevin was doing his own math, I showed him the post where they came out with the kit.
Yeah.
And, Kevin and I talked long about this, and, that's why we're kind of pushing the things wear out. Because, some people are pretty hot about that. And
thinking that they should just give them away. And I'm like, no.
Well, again, everything's now, if they just bought both sets and 2 days later that happened, that's a different story, but that should be covered under warranty.
Yeah, it's a warranty.
We're not really going to get into the politics of it, because, again, steps are expensive. Even my amp steps were expensive, and I look at the fact that I had to replace a motor eventually, and it's $120.
Yep.
And guess what? Those steps have been on that Jeep since the beginning of 2019.
Mm-hmm.
And my 200 plus pounds has been stomping on those things.
Yep.
So therefore, to me, that's considered a wear item.
It is, and that's the thing, folks. You buy tires for your Jeep. Mm-hmm. They wear out. They cup. They get edges worn off because of your shocks or your alignment's bad.
They get a chunk taken out of a rock.
Right. That's not the fault of the tire manufacturer.
Mm-hmm.
Okay. Now you get a brand new set of tires and you drive 50 feet and the belts delaminate. AKA Firestone 500, then maybe you go back and talk to people.
Firestone 500. Here we are, showing our age again.
Sorry, but they can Google it if they want to see it. But there is logic that applies to all of the above. The fact that Metal Cloak took the time for a product line that has been out of service 2 generations.
Metal Cloak or Rock
I'm sorry. Rockslide Engineering has gone back 2 generations and come up with a upgrade. Okay, it's not a repair kit per se. It's an upgrade from the initial technology to the current technology. I think is a pretty nice idea that they did that.
A lot of companies would have said, buy the new ones.
Yeah, that's would have been the answer you get from most folks is, well, buy yourself a new one. They said, well, we know a lot of people run these steps, and here's an option for you. Mm-hmm. And you know what? Versus $3,000 for a new set of steps, $100 for a refit.
Or if you have time, tools, and all that, you spent less than that. But then again, you had the time, the tools, and
a little bit of the smarts to figure out what was going on.
To figure what's going
and the
on.
willingness. And actually, it's not even willingness. It was the I won't figure this out.
Well, and again, if you have questions about this, that's fine. Just we're not here to take away their kit.
Yeah, their kit is a good kit. Mm-hmm. I made some different choices in my plan, but I wasn't replacing
Gen 2.
The RAM system, that type. I'm supplementing it for a different reason.
Yeah.
All right. What I'm happy to report is that, okay, with a little bit of play, you can put them back to as good as new or maybe even a little bit better. But if you've got a set that's got what they call the droop, their idea of droop, mine was just the leading edge of the step when closed was hanging down a 1/2 inch. So my rock slide, using that as a straight line, you'd see the nose of the step kind of dripping down. The back was tucked up tight. Mm-hmm. So that was out of square is the way to think of it. What they're talking about is the ram's age, that there's just not enough power in the ram and the motor together to make it that last few degrees, because as you get higher in closing a parallelogram, more of that force just is pushing on the bearing and not lifting. So there just wasn't enough lift for those last anywhere. I saw one that was drooped like 4 inches. Another one was only drooped 1 inch. So they're saying, hey, there's a better thing than the gas ram. Now, you can replace the gas ram, too, and I know that personally because I replaced one of my gas rams years ago and was able to source a 40-pound because all the data's on the ram. So I was able to source one and put it in and restored functionality, just the same as you replace an oil filter when it's full of crud. I just took a wear part, put a new part in. The difference is they're going with a technology that doesn't link down. To go a little deep, just to give you an idea, I looked at things that the actual range of motion of the pin is only about 2 inches. Okay, that's the pin on the arm that's being pushed up, moves about 2 inches. But they put a 6-inch spring. Now, why would you put a 6-inch spring when you only need 2 inches of movement? Because you can cycle a 6-inch spring 2 inches thousands and thousands and thousands, probably hundreds of thousands of time, and you won't fatigue it.
Right.
You take a 4-inch spring and move it 50% of its length, you are going to be stretching it, and you may deform it. If you put a 3-inch spring in, you will deform it, and it won't go back. You follow me? So they took the time to even figure out spring geometry. So my hat's off to them, guys. Thanks.
It took some engineering. Again, Rockslide Engineering.
Yep.
The only other thing I want to touch base, because we're getting close to the end here. Another group talked about a person's having a problem with their JL. Kevin and I preach this about being patient. A lot of manufacturers are still having problems, getting parts. So if you find yourself with your Jeep at the dealership, again, be patient, call the Jeep customer care, do stuff like that. And just remember, you're dealing with a human being on the other side of that counter.
Yeah.
Just take
Who
a few
really
minutes.
has no control over the supply chain, the design team, whatever.
And
So,
but they don't get paid till the ticket gets closed. So trust me, they want that part just as much as you do.
Yeah,
So that was just my little. Again, just be patient, people, because I'm hopefully back in the workforce by the time this show comes out.
yeah.
So
he is on the prowl for reemployment now that he has come to terms with the rather. I won't say the words, you don't have to bleep it out, deal that he received from life over the last 2 years.
That's okay. Another thing upcoming is Mark sent the PCM beginning today.
Oh, yeah, that's right.
And then because I'm testing to see if all the gauges work, because you had a better way to say this. What was it?
The thing is the co-founder of Wrangler Fix, we've talked about them before. They've become a friend of the show. Has asked Scott to do a little bit of beta testing for him. And what it is I did the beta test on the kind of pre-hot rod tuned ECU.
Right.
And he is doing the same for Scott, but he had a question. I don't run a Trail Dash or other computer monitor. I say, my TJ is my TJ. It's an old straight six. I'll listen for the ticks, the bangs, the thumps, and the booms. Scott,
I'm the hypochondriac over here.
He is. And so he has his Trail Dash and he's got his transmission monitor and these and that. Well, the question is, will the modified PCM still report data the same way as the unmodified PCMs would be? And will the Trail Dash function? Now, it will not program because, as we've said before, the revisions that Wrangler Fix does moves some of the data storage locations around to bypass known flawed areas in various models of the computer systems. And that is to get you out of the classic failure modes that the TJs had, just using it as an example, where out of a sudden it'd suddenly tell you had all four O2 sensors were dead. And you change them, and they're still dead. And you know, nothing really worked. And you remember there was all kinds of posts. Well, you got to use factory ones. Okay, you'd put factory ones in, and it might fix it, and it might not. Well, it turns out that it really wasn't the O2 sensors at all. It may have started with an O2 sensor overheating, and there was a spot in the circuit board that couldn't take the stress, and then it would go to crap. But it wouldn't error out. It would just falsify data, so to speak.
Yeah.
And Mark and his team figured these issues out. What was the cause of these, check engine lights? I mean, they're going to un-Americanize the Jeeps if you're going to be able to run it without a check engine light. Sorry, Mark.
This little light of mine, I'm going to let it shine.
Yes, and that's kind of thing. But see, Mark's the kind of guy who looked at it and says, I don't want to let it shine.
Yeah.
I want it to tell the truth. Mm-hmm. And he's come up with that. But in the process of moving data around a memory, the programmers are set up they go in and they change a specific memory location value to change the program. Well, it ain't there anymore.
Yeah.
It moved 3 doors down, 7 layers up.
Yeah. Great band, by the way. 3 doors down.
Yeah. So
sorry, just a byline there for a second.
So now, while we've proven that it works. Okay, the tune works. I love it. The question is now for guys like Scott that want to monitor, who needs the digital dash.
The hypochondriac.
Yes, the guy who spends his whole life looking at his phone.
Look, I made it an hour.
Yeah, you did.
Well, not
no,
really.
you didn't.
No, I didn't yet.
Go ahead, lie online. But anyhow,
it's the internet. It's used to being lied to.
It's true. It's the truth that scares it. So as soon as it gets, Scott's going to throw it in his Jeep, and we'll see if he wants some help there or not, and we'll go on from there. Let's see.
Well, he did say 3 screws and 3 plugs. He should be up in it within 10 minutes. So we'll see how long it takes. Because this is me we're talking about.
This is true.
Get ready for the I need an adult, Kevin.
How many times are you going to drop the screws?
You just had to say that.
Yes, I did. Let's see. Last thing.
Aaron packs it to 3. I'll get this sucker in.
Oh, God help us.
It's like
First off, I have registered, and at least at the moment, my wife and I, we will be attending the Bantam Jeep Heritage Festival. It's actually in Slippery Rock, Pennsylvania, as part of a little round robin, because that whole central PA area is, I won't call it my hometown because I'm actually a military brat and kind of lived all over the
The
place.
planet is your hometown.
Pretty much, yes. And there were times my mother threatened to send me off planet. But
To the moon, Kevin.
yeah, pretty much. But no, so we're going to be doing a lot of visiting, but we've got our registrations. And so I look forward to any of you up in the central Pennsylvania area to get up there, to go through the whole Bantam Festival. And yes, I know the Jeep was not founded in Slippery Rock, but that's where the festival is held at the center. So we're actually staying over in the correct town. I'll put it that way. And what?
Nothing. I'm just agreeing. Like that's cool.
Oh, okay. So that's where we'll be. We have some upcoming work on the GPW, which will happen in a couple of weeks. It's not anything to do with the GPW setting the time. It's right now there's something going on with hotel rates and my time to get back across the state.
Yeah.
To on a suitable day when the GPW owners, plural, are available to do some equipment swapping.
Yeah.
And we'll report on that later. It's a lot of fun. Let's just say the current status is it's really hard to start.
Yeah.
So anything else on your end, Scott?
Not really at the moment. I want to sandbag some subjects for the next show. But
Okay.
if you have a subject you'd like to ask and a question for the TJ Guru, you can go ahead and email us at onthetrailpodcast@gmail.com.
You waited
like how I
all-
waited? I've sat on that till the entire show.
And I don't claim that title, folks.
No, that was a gift
Kind of
title.
thrown like me at mud, in a political fight. Splat.
But no, and Kevin does know his, and I don't really take it personal. I mean, because Kevin does know his stuff. Because I'll answer the question in like 5 words. Yeah, Jeep good, Angawa, and Kevin will actually use much more gooder words. But the point is that again, I know no one asked for my fart jokes, so that's besides the point. But other than that, I mean, if you do have a question on the trail podcast @gmail.com, Facebook Messenger, pretty much get in touch with us that way, and we really appreciate the feedback, guys and gals.
We do very, very much. I guess the other teaser I forgot to throw in earlier is we are seriously looking at getting to SEMA 2023.
Yep.
If you're interested in that and hearing about it, let us know because it might increase the efforts a little bit if you want to hear for it. And I'm kind of looking forward to it. But of course, I'm going up to Bantam headquarters, and which is really funny because I realized how much Autumn wanted to take. I thought it'd be cool to take the GPW there, but that may be suicide.
Why is that?
That was made by Ford. You're going up
I'm
with a Bantam?
sure it won't be the only GPW there.
I got news for you. There's only one Bantam Jeep. Remember that. The rest of them are either made by Kaiser Willys or Henry Ford.
Hey, at the end of the day, bullet holes and street cred. That should get me. That should get her laughed at less.
We just got to work on the Bondo and the wiring that goes snap crackle.
Well, the interesting thing is that she wanted a Bronco, and I'm like, well, but she wanted a Jeep, so now you kind of got a Ford Jeep.
She does.
Yes.
Yeah. It even has the Ford logos in appropriate spots.
Before we start getting Bronco hate mail, I think it's time we hit the Jeep.
Hey, I owned one. Cut that out.
Well, yeah, and you're helping a friend with one too.
I am.
I think it's time we put the Jeep in 4 low and hit the trail.
Yep. So everybody, please remember, take nothing but memories, pictures, and of course, always take your trash
When you leave the trail.
when you leave the trail. We want to keep them clean and open for our children, our children's children, and hopefully generations beyond that.
Exactory. So with that, we're going to sign off now. We look forward to the next show, 180.
180.
Oh, now we're going to have to talk about Fords, do a complete 180. And welcome to Bronco Cast. This is Scott. I don't own one. Kevin, that did own one. Today we're going to talk about... No, I won't do that anymore.
I will disavow any knowledge of his behavior and activities, and we'll make the evidence disappear.
Why are you on Amazon looking for jugs of acid? All right, with that, folks, have a great day. We'll talk at you later.
Bye.
Bye.
Proceeding has been provided for entertainment only. Proper service and repair procedures are vital to the safe, reliable operation of all motor vehicles, as well as personal safety of those performing those repairs. Standard safety procedures and precaution, including the use of safety goggles and proper tools and equipment, should be followed at all times to eliminate the possibility of personal injury or improper service which could damage the vehicle or compromise its safety.
What he said. Thanks a lot for listening, guys. You guys have a great day.
Bye.
This has been a Bent Axle Media production.